My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 580. In this lecture, we will try to understand Softmax classifier, Softmax and cross entropy for multi-class classification. So, we all know the logistic regression very well because we have seen it multiple times. In this lecture, we will learn about generalization of logistic regression called the Softmax classifier. Remember, logistic regression effectively solves binary classification. If you have to solve multi-class classification using logistic regression, we use the one versus rest method. But is there some way to take the core idea of logistic regression, mathematical concept of logistic regression, and extend it naturally to a multi-class setting? So, literally, logistic regression for multi-class setting can extend the basic mathematics of logistic regression to multi-class. What you get is Softmax classifier. I will show you how this extension works. Instead of using the one versus rest scheme, you can gracefully extend the mathematics of logistic regression to multi-class using the concept called Softmax classifier. Before we go to Softmax, let's understand logistic regression from neural network perspective. Just try to recall, we have a bunch of inputs here. What is your input? Xi, isn't it? Now we have sigma term here. Basically it is sigmoid function, and you have yi cap here. Yi cap equal to, what is this? Probability of yi equal to 1 given xi, isn't it? That's what it is. This is the probabilistic interpretation of logistic regression. Input to sigma is your zi equal to xi transpose w. P of probability of yi equal to 1 given xi, which is equal to, I can say, yi cap, isn't it? Your yi cap equal to sigma z. Why? Because for sigma, which one is input? Z is input. What is the sigmoid function? Looks like sigma z equal to 1 by 1 plus e power minus z, which is equal to e power. If I multiply with e power z in numerator and denominator, I will get e power z by 1, e power z plus 1. I am just recalling what we already know so that it's graceful move to Softmax. This is your logistic regression. Now let's understand Softmax classifier. There is a very nice visualization. Just this is from stockexchange.com. Just Google for it. From stockexchange.com, you will get this pic. So what it does, this is, let me explain this image for you. We have just try to recall once our logistic regression neural networks perspective. We have input here, we have weight z equal to xi transpose w. What is my probability of yi equal to 1 given xi? That is equal to yi cap, which is equal to sigma z. This is for two class classifier, isn't it? Here what do we have? The Softmax classifier is simply saying, imagine your data set d equal to xi comma yi. Let me say my data set is d equal to xi comma yi. Your yi belongs to, what is your yi? In the case of logistic regression, yi belongs to 0 comma 1. This is binary classification problem. That is logistic regression, isn't it? In the case of Softmax, Softmax, what is your yi? Yi belongs to 1, 2, 3, so on k. Let's assume we have k such classes, isn't it? Let's assume 1 2 3 so on, k means what? You have k such classes. So what do I have to do, I have to return here? Let's assume we have k such classes, isn't it? Class 1, class 2, so on, class k, k such classes. So what do I have to write here? So let's assume I am building a model here. My input is xi. What is the output? In the case of logistic regression, you are here, as I told you, here I have k classes. What is my input? Input is, let me assume xi. What is the output in the case of logistic regression? My output is yi cap, isn't it? In the case of in the case of logistic regression, I am generating only one output, that is yi cap. What is that output? The output is probability that yi equal to 1 given xi. If I know this probability, the probability of yi equal to 1 given xi, you have only two possible outcomes, isn't it? What are those two possible outcomes? 0, 1. Yi belongs to 0, 1. Let's assume this probability is 0.6. Which probability? Probability of yi equal to 1 given xi is 0.6. If somebody gives me this probability, I can easily compute probability of yi equal 0 given xi, because there are only two possibilities. This is nothing but probability of yi equal 0 given xi, which is equal to 1 minus 0.6, which is equal to 0.4. So the probabilistic interpretation of logistic regression, isn't it? This is a probabilistic interpretation of logistic regression. If I have just this probability, that it belongs to 1, means if I have probability of yi equal to 1 given xi, so that you will get a probability of belonging to other class. On the other hand, here I have, just see, here I have how many classes here? I have k classes. Yi belongs to 1, 2, 3, so on k. I need probability of yi being equal to class 1 given xi. I also need probability of yi equal to 2 given xi. I need probability of yi equal to 3 given xi. So on, probability of yi equal to k given xi. If I take sum of all these probabilities, which is equal to 1. In the case of binary class classification, if you know probability of one class, we can find probability of other class, just like logistic regression. Even in this case, in the case of Softmax Classifier, if you give me the k minus 1 classes probabilities, means first class, second class, till k minus 1 class probabilities, I can compute kth term probability, because sum of all probabilities is equal to 1. So this model, what we have here in a multi-class setting, simply generalization of logistic regression to multi-class setting. Such a model is called Softmax Classifier. Let's go and understand the mathematics behind it. So you have your inputs. What are your inputs? xi1, xi2, xi3, so on, xid, isn't it? Here you have slightly different notation. I will just explain this to you, or else we can also redraw it. I have my xi1, xi2, xi3, xid. It's a d-dimensional point, isn't it? Your input is d-dimensional point. And remember, what should a model return? A model should return k probabilities. My model should return, what should this model return? K probabilities. That's what it says, isn't it? So I basically have k functions here. Let's call them sigma 1, sigma 2, sigma 3, sigma 4. Let's assume we have 4 classes. Let's assume k equal to 4. What does it mean in this particular context? K equal to 4. Just for this diagram. So what happens now? All of these points will go to my first model. All the inputs will go to my first model. Similarly, all of these inputs go to second one. Similarly, all of them go to third one, and all of them goes to fourth one. Now, whatever the output of sigma 1, sigma 2, sigma 3 and sigma 4, the most important thing is all of this output sum is equal to 1, isn't it? The most important thing is all of this output summation is equal to 1. Why? Because all these are probabilities. It is very important, and they should have probabilities interpretation. So the way it works is, so let's assume there are 2 weights to each of them. Let me assume these are the weights. So I have a d-dimensional input xi1, xi2, so on xid. Weights are associated with it. This is your w11. Just we know how to, this is your you have w11 output, you have w11 weight, w21 weight and w31 weight. Now sigma 1, sigma 2 are look like as follows. In the case of logistic regression, what is your sigma z? Your sigma z equal to 1 by 1 plus e power minus z. In the case of Softmax classifier, let's assume the input you get at sigma 1, let me assume that input you get at sigma 1 is z1, isn't it? Input at sigma 2 is z2. We know how to understand this z1 and z2 in our introductory classes only. We discussed all these concepts. Input weight, input that we get at sigma 3 is z3, isn't it? The input that we get at sigma 4 is z4. What is my z1? As we are discussing, we know what is z1. What is z1? So j equal to 1 to d xi is a wj1, isn't it? We know what is z2. Similarly, now you have inputs. Now we will define z2. What is my sigma 1 z1? E power z1 by sigma I equal to 1 to k e power zi. That is sigma 1 of z1. Here how many z's here? z1, z2, z3, z4. Isn't it? Here k is 4. You have as many jets as your k's. K is number of classes, isn't it? That is sigma 1 z1. So this is defined of this is definition of sigma 1. What about sigma 2? My sigma 2 is sigma 2 of z2 is e power z2 by sigma I equal to 1 to k e power zi. I request all of you to understand to this particular stage, so that I will continue my discussion on Softmax classifier in my next lecture, that is in lecture number 581. Thank you very much.